welcome. I am Emily Blanford. I'm a developer in the Configure at Grand Rapids office. I work on the production team, so I work mainly with client and customer projects. Okay, so the topic today is quirks of the CM language, or what I like to call what puts the magic in CM. So what do I mean by that? This presentation is pretty much going to be just like a combination of syntaxes that you might not know about and behavior that you might expect something different based on what you know from other languages. So we're going to talk about the high level of like what is CM, using the ... syntax to pass arguments into methods and functions, some uses of the question mark, weird behavior with scope, unknowns about maps and sets, a few different ways to check equality, special keywords, anonymous functions, and XAPI. Okay, so what is the CM language? Well, it is Configure's own proprietary language, and it stands for Configure Magic. As far as I know, that is true. The original platform was programmed in C++, but this left a desire for a language that was customized to our own specific needs. Hence CM was born. It is OO. It's strongly typed, meaning the type is required. Similarly, like Java and Python are also strongly typed. It's statically typed, meaning the type is known at compile time. So even though sometimes it might feel dynamic, like the newer editions like PropObj and XAPI kind of make it feel a little dynamic, but it's still very statically typed behind the scenes. So I guess the first thing I'm going to jump into is using the ... syntax for your arguments. I hope everyone here has seen this before and probably used it, especially with like supercalls. It's kind of similar to JavaScript's spread ... if you're familiar with that, but CM only works with arguments. So how do you use this? Well, if you're inside of a function or a method and you're going to call another function or method with the same or some of the same arguments, you can use this parentheses ... syntax as a shorthand instead of typing out each variable. So it does also respect the current state of the local variable. That's something worth noting. I'm going to show you several enhancements to this syntax, and then also something to note is that it can improve readability if you are using it correctly. Not always, but I'll show you how to use that. And then one other thing to note is that it's only useful when the method you want to call's parameters are in the same order and are consecutive. So it won't be useful if you need to pass in arguments in a different order than your caller, or you need non-consecutive arguments. So what I mean by this is if you need the first and the last argument, this won't work. Okay, so the first example that I have here is just a simple example of how this can be used. So like I mentioned, it can be used for super, but something that I actually learned recently is that it can be used to call any function or method that has the same parameter types. So here you can see function 1 has 3 doubles and function 2 has 3 doubles. I can actually use the ... here instead of typing X, Y, and Z. So you can see it like that. And then also something to note, like I mentioned, it does respect the state of the variable when you use it. So if I change X to 4, 4 is going to be passed in. And something, just a fun fact, you're probably going to see this used a lot today in my examples. This is call frame dump or compact function dump. It's just a friendly debug tool that you can use, and it just makes a nice print statement from your function. So it'll do your function name and then your parameter ID and value, and then If you're calling this from a method, then it'll also include the class name. Okay, so this example is just to show you that you can combine the dot dot with other arguments. So you can add your own additional arguments to either the beginning or the end of the dot dot. The dot dot just kind of acts as its own argument, I guess, in a sense. So you would just treat it like its own argument. So it must be separated by a comma. But yeah, you can add as many as you want to this. I guess I should show you that. Okay, so this one is a little bit weirder. Maybe you haven't seen this as much before. You can actually add a dash to your dot dot just like this. So no spaces or delimiters. And then what this does, it actually removes an argument. So if you add this to the end, like you see here, it would only pass in X, Y. I can also add it to the beginning and it would pass in Y, Z. I can combine as many as I want. I think there's not a limit. And I can also add it to the beginning and the end. So that's something to note. It just basically removes something from the list depending on where I put it. So this is what I was talking about with, it's typically easier to read if you're using dot dot, but if you have a bunch of dashes, it could get difficult to read. So I would say probably try and limit it to one or two. If you just need to remove one at the beginning or end, this is really useful. This is similar, but not quite the same. So this is actually the newest enhancement to the dot dot syntax. I think it came out in 9.5. So you can actually place a vertical bar or pipe, as some people call it, after one of your parameters, and then you can indicate whether you want all the arguments before or after the pipe. So here I've placed a pipe after Y. So if I use dot dot pipe, it would give me X and Y. So it would give me all the parameters before that pipe. If I did pipe dot dot, it would give me all the parameters after the pipe. So it would be Z in this instance. You can see that there. So this can be added or removed or moved in overridden methods. So if your super class doesn't have this, you can still add it or move it if your super class does have this. And then something to point out is that this can't be combined with the dash, but it can be used with adding additional arguments, as can the dash. So the dash and the vertical bar can both be used with additional arguments in the same way that the regular dot dot is. Okay, CM, this isn't really super related to the dot dot, but I thought it was kind of cool and worth noting. CM has a syntax called REST, and this is not the same as REST API. For those familiar with web development, this is nothing like that. If you know about JavaScript at all, it's closer to like the ellipses where it'll make an array of whatever's passed in. So basically, if you have an unknown number of parameters, but you know the type, you can add REST colon with a sequence of your type. And it must be a sequence. It won't work any other way, but you don't have to define a default because it will default to null if you don't pass in any parameters for it. So you can see here, if I just pass X and Y in, anything is equal to null. If I pass an additional argument in, then it will populate anything. Okay, so the magic question mark. I've heard this term before and I really liked it. So basically it's just like CM has a lot of question marks sprinkled throughout its syntax. You've probably seen them. Maybe you know what they do, maybe you don't, but I just wanted to go over a few of the examples of the use of the question mark. So if you see a question mark in CM and you don't know what it's doing, it's probably a good guess to assume that it's doing something with null checking or null safety. Otherwise, it's probably casting. And like I said, I'm going to show you some use cases. I'm probably missing some, but these are the ones that I know about. So this first one, you can see that I have an append and then I have a question mark after the append operator. So without this, it would always add I to in sequence, but with this, you can see that it will check if I is null, and if I is not null, it will append it. If I is null, it will not append it. So if I could potentially be passing in values that are null, it's good to have this question mark if I don't want to be adding those to my list. Similarly, the plus equals and the minus equal operators have this syntax as well. So it just does the same thing. It checks that you're not trying to add or subtract a null, I guess, list from the other list. Another use of the question mark is the double question mark. As you can see here, what this is doing is it's checking A for a non-null value. If A is not null, then it'll evaluate to A. If A is null, then it will evaluate to B. So something to note here is that even if B is null, it will still evaluate to B if A is null. So it never checks B for null. So just keep that in mind. It's kind of similar to like ternary, which I didn't include in here, which is just the question mark colon. That's pretty common in like most languages, so I didn't include it, but it's basically the same thing, but the condition would be like A does not equal null. And then there's just another use case for it. And then you can also do stuff like setting something equal to this or that. So you can use this in a lot of different ways. So this slide has a few, well, two different things that I wanted to point out. So the first is the init syntax. So for those of you who don't know what this is, it's just initializing your ID using new and whatever ID's type is. So I guess in this example, if you can see my cursor, it would just be removing that if not in sequence. So it would just be this last part, int sequence equals new int. So that's what init is doing. And then it also has an optional condition, which would be a question mark. So I can add this question mark to init. And what this does is it checks to see if int sequence is null. So has int sequence been initialized yet? If it hasn't, then initialize it. So if int sequence is null, it will initialize it. If it's not null, it won't do anything. So something to note here is that it will null check every time, which is a bit of a performance hit, but not too much. So I like to use this if I don't know if I want to initialize something unless I'm using it. So you can add this in here before you add to it. So you can see here in sequence is not initialized, and then I go to add to it, it'll initialize it and then add to it. Something also worth noting is that if I didn't have that there, it would still compile, but it would throw an access violation at runtime. Okay, finally, there's this question mark, which I'm probably sure everyone has seen here, but if not, what this is doing is it's checking my object to see if my object is null before making the method call. So if snap2 is null here, return true won't run, but it will evaluate to the default value of my method or function's return type. So what I mean by that is return true has a return type of bool, so it will return the default value of bool, which is false. So res2 will equal false, but not because res2's type is a bool, but because return true's type is a bool. So this is null safe, but if that were like an int that would return true, we're returning, or if I was trying to cast it to an int, I believe it would not compile because the types wouldn't match. Okay, and then I also mentioned that there's a case of the magic question mark being used with casting. So this is what I mean by that. You can add a question mark to, I guess, as a shorthand for casting. So here, instead of typing bool b2 equals b1 dot bool, I can eliminate the need to type bool twice since I already have defined my type that I want to cast to. So if I add this question mark in front of bool, it will be the same as typing b1 dot bool. This is null safe, so it's actually more like typing dot colon, but for the sake of this presentation, it's just doing a cast. So something to note is that it does behave differently inside and outside of an if statement. So if I use it outside of an if statement, it will cast to the default value of whatever I'm trying to create, so B2. So here, B1 can successfully cast, it will be false, so B2 will equal false. So if I pass B2 in here, B2 will be evaluated, which is false, so therefore it will make it into B2 did not make it in. It will be in the else. However, if I do this inside of an if statement, it is actually checking to see if the cast was successful, not the value. So even though in the second case here, B3 will equal false, the cast itself was successful, therefore it will pass this if condition. So it will get into B3 is successful. So that's just something to note, that they do behave a little bit differently and something to watch out for if you're going to be doing this. And then here's an example of what happens if you are trying to cast and the cast is not successful. So you can see that it will cast to my default value, which here it's an int, so it'll cast it to 0 outside of this if statement. If I'm inside of an if statement and I try and cast my object, which is a bool, to an int, it will not be successful, so I will get into the else block. So just some odd behavior with this. If you're going to be mixing them up, they do just behave differently. Okay, I guess this is a good place to see if anybody has any questions before I continue. I will take silence as a no. Okay, well, scope has some interesting behavior in CM. The first thing that I wanted to point out is that private modifiers are file and not class accessible, and that variables declared inside an if statement perform differently than variables declared inside an if statement with a condition. And then lastly, what happens when you're using a function or method as a default argument. Okay, so private modifiers, like I just said, they're visible within the file, not the class, which I think is standard for other languages. but this is because you can see here that I can define a variable or a function outside of a class. And so these can be in the same file as a class outside of a class. Therefore, I can make them private, but visible to the class within that file. So what I mean by that is if you see I have class 1, I can access private variable, no problem. Things do get kind of weird if I have multiple classes inside the same file though. So you can see that class 2 can access class 1's private method. So if I'm using multiple classes in a file, I can access any privates in that file. Although I will give you the friendly reminder that it is code convention that you only use multiple classes in the same file if they fit on one screen. So if you have small classes, it's okay. Like these would be fine. But if your classes are larger than one screen, please just put them in their own file, and then this doesn't really apply. Okay, this is kind of an odd case actually that I stumbled upon, and I'm not sure if it's supposed to work this way, but I wanted to point it out because this could definitely be a big issue if you did this. So here you can see that I have my private int num, and I'm using that as a default for my argument x. So what I would expect to happen would be that no problem, my class has access to num, and it would just work. But what actually happens is not that. So this is actually still within the same file. So you can see that I can access my test class.num no problem. But when I try to call my num using that default of num, it can't access it. So it doesn't know about it. So I don't know why it behaves this way, but I would say probably just avoid using private fields or methods as your default arguments, because you're not going to get the behavior that you want, and you're not going to be able to use them. All right, declaring variables inside an if. So I was showing you guys how to use this with the casting, this magic question mark. You can use it, you can declare, I mean, you could declare a different variable without casting inside this as well, and it would work the same way. I don't know why, but all my examples have casting. So I guess this kind of behaves how you would expect it to. So I'm making a variable inside an if statement, and it's local to that if statement. If I try and call it outside of it, it won't exist. So it is local to that if block. This is because it is declared and defined within the scope of the if expression here. But things are a little bit weird if I try and use this with the condition. So this could be any condition. You can see here I've got just a regular true. The not is also considered a condition. And then lastly, I'm trying to use the variable that I just defined. So these are all considered conditions. So what actually happens is that it's declared outside of the if statement, and then it's defined inside of the if statement. So it's actually going to be local to the caller scope, not the if's scope. So you can see that I can access it inside, cool, but I can also access it outside. So it's just something to note. And then even weirder here, you can see that it declares outside of the if, but since I bail out early with that false, it won't define it. But you can see that it's still it still exists outside of 5. Okay, and then this is kind of similar to what I was talking about with the second private example, where I had a private as my default argument. So functions as default arguments, I guess you would think that if you make a default argument with my num, that it would be 2, but it actually respects the caller scope, not your class scope. So here, if I call test class set num, it will be a default of 4 because that is my scope, the caller. And then also something to note that if I did not have that global variable or that global function there, my num, then it wouldn't compile. Okay, maps and sets. So here I just want to talk about some cool stuff that maybe you didn't know. So I've seen a lot of people not know about how you can initialize when you declare a map. And then there's some plus, minus, and multiply operators for maps and sets that have neat behavior. And then this doesn't work for sorted maps because they're actually implemented with a tree, not a hash table, but I'll point out what they do. So you've probably seen this before. I think this is probably how most people will make a map. So you'll define it and then you'll just append to it using put. But you can also do this. There's a friendly syntax that helps you declare it in the same line. So it would just be this statement, and then you use the arrows to signify the difference between your key and value, and then commas to separate the key values, and then a semicolon at the end. If your cast is not implicit, then you can cast your first value, and it will try and do that for the rest of the values. Okay, map addition. So when you use the addition operator on maps and sets, you're merging them. So what that means is the left will take priority and any unique keys from the right will be added to the left. Order doesn't matter for sets. So here you can see that I'm adding the map 1 with map 2. Map 1 is my left, so those values will take priority. So even though width and depth exist in both maps, map 1's values will take priority because it is the left map. And then it will add thickness to map 1. When you use subtraction, you're getting the diff between the two. So the result will be the left map with any common keys removed. So here you can see width and depth are my common keys. It would remove those and I would just be left with H because that is my left map. If I did map 2 minus map 1, I would be left with thickness. The multiplication operator on maps and sets is the intersection. So it will result in the commonalities between the two. For maps, this will use the values from the right map, not the left. So the common ones are width and depth, but it will take the values from the right map, not the left. So the values will be 4 and 5. If I reverse this, the values would be 1 and 2. Equality. Okay, so I guess here I just wanted to point out that there are different ways to check equality, and they mean slightly different things depending on your type that you're checking and I guess what you are trying to check. So the double equals operator is a pointer comparison if you're checking reference types, meaning like, is this actually the same reference? That's what it's checking. For value types, it's a value comparison. It works a little bit different for precision types, but I'll show you that in a few slides. And then you can override the double equal operator by just doing like the bool operator double equal within your class. And then you can also declare your own value types and override this. And then there's also dot equal, sorry. And this is a method that lives on object. This is a value comparison, so it will check your fields. And then it also can be overridden because it is a method. So this is what I mean by the double equals. It doesn't necessarily mean the same thing as dot equals. Here you can see I've created two instances of my object. They do have the same field values, but object 1 and object 2 are different instances. So the double equals will return false here, but dot equal will return true because I have field A for both of them and it equals 2 for both of them. So my field values are the same. The second example, you can see that I've actually created the same instance twice. So object 3 and object 4 are referencing the same instance. So object 3 double equal object 4 will return true, and as will dot equal. Something to point out here really quick is that I am using the static field modifier. For those of you who don't know what that is, it's just indicating that this is only created once. So any future calls to single object will return the same obj as the previous calls. So this static my object obj to line will only be called once. I think there's a lot more to it, but that's just like quick and dirty. Also, there's more examples in Emacs. If you go to Emacs, CM examples, CM syntax, equality, there's that bar at the top. Okay, so I mentioned that precision types are a little bit different. So what I mean by that is like doubles and points. I know for double, there's a function .eq that is actually being called when you run the double equal operator. So that does a precision, I think, of 10 to the -6th for comparisons. Same with the greater than and less than. Greater than, I think, is GT. But anyways, if you wanted something less precise, you could override that and give it a precision. So you could call .eq function directly. I didn't put an example of that in here, but that's something to note. But also there's something that's new-ish to this syntax where you can add exact to an operator and it will give you the exact equivalent or exactly greater than. It will check the exact precision value. Okay, keywords. They're decorators that you can add to fields, classes, functions, methods, and enums. They always look like this with the colon keyword at the end of your declaration. If you need multiple, you can separate them with a comma. There is a great wiki article on this that lists, I think, all of them. So if you want, I'll leave that up for a second, but that's a really good resource to check out like all the different keywords that are available. I will go through a few of them that I think are cool, but yeah, if you want to reference that as well, it's a good resource. Okay, the field keywords that I like are copy equals reference. So this can only be added to reference type fields, but it will return a reference to this field when copied. So if I copy a field with this on it, it will return a reference to that field. It will not return a deep copy. Similarly, copy equals null will return a null or a 0 or whatever the default value type of that field is. Stream equals null. This means that this field is not streamed at all. So if you decide to add or remove this later, you're going to get a load failure. So I guess just be mindful if you're going to use this that you know that you want it to be stream equals null. It is really good to have this, but just make sure that you're not adding or removing it in released code without considering that you might get a load failure. Well, you're going to get a load failure if you're messing with it. Okay, public readable and package readable are, I guess, a way to make private fields visible outside of your file, but still maintain full control over what's written to that field. So instead of making something public or package, you could use the private modifier still and then make it public readable. So only my class can change W here, or only my file can change W here, but any file can view what W is. These can be added to classes. So similar to copy equals null on fields, there is uncopyable on classes. If you add this to a class and then you try to copy that class, you'll get a compile error. It will tell you that the class is not, it's got uncopyable. So it just won't let you. Unstreamable is instances of this will be omitted when saving to stream. So just won't be streamed. And then replacing load is kind of a weird one. It signifies that you may be returning a different instance of this same class in loaded 0, replacing the existing instance, but it has to be the same class. So I don't know that it has a lot of use cases, but I guess like if you really wanted to, you could use it. It's different than the renamer. I got that question last night. So the renamer is doing what it says, it's renaming your class, but this is actually saying like, I want to return this exact same class, but just a different instance of it. Okay, so the null equals semicolon or the null equals a default value. This can be used on both fields and functions and methods. So I'm saying functions and methods is the same thing. It is saying if I have a null pointer, return either null or the default type if I define that. So I think I tried to put the semicolon on my int here and it did not let me. So I think you do have to have like at least of the default type. So I can't return null from an int. So it would need to be like a 0, or I could put any value there. I could make it a 2 if I wanted. So this is saying like, yeah, if I'm calling this with a null object, then return that value or null, whatever I've put there. If it's a semicolon, it'll return null. So it's kind of similar to like that null check that I showed you earlier with the magic question mark, except that this is going to actually null check your pointer every time that this function or method is called. So there's going to be a bit of a performance hit if you're calling this function or method a lot. So I don't know if this has a lot of use cases, but it is pretty cool that you can do this. One last thing to note is that you can only add this to your extended methods, so you cannot add this to any overridden instances of your method. And then finally, this field access keyword on enums. I hope everybody is already using this if they're making enums. What this does is it just makes your variable name a little bit more specific so that you're not running the risk of running out of variable names or potentially trying, like you wouldn't be able to reuse 1, 2, or 3 if you did this. And then also a lot of times, like if you're making an enum, you might want to use none as the first, your first enum value. If you were not using field access, you could only use that in one of your enums, and then the name none would be taken. So if I add field access here now, my names are numbers.1, numbers.2, numbers.3. So to access them, I do have to call numbers.1, numbers.2, numbers.3, but it does help with making the names more specific. Okay, anonymous functions are pretty new. I put that location there if you guys wanted to check out where that syntax lives. I think they're new as of 10.5. But yeah, so that's where it lives if you want to see what that syntax looks like. This is how you would both declare and define an anonymous function. However, and that's how you would use it. So if you wanted to say, I want to create an anonymous function that's called add fun or twice the fun, which is kind of odd because I think it wouldn't totally be anonymous at that point. That's how you would do it. But more likely you're going to want to be using it like in line like this. So here's a good example of how you would do that. So here you can see I have a bool callback lim, and before this I would have to make a function callback of change bool value. So I'd have to define my function change bool value. Now I can do it all in line in this single line. So I have my f, and then my arg type, which is a bool, my ID type, which is v, and then I am returning a void here, so I actually do not have to include this arrow and return type. I can just exclude it altogether. And then I have my statement, which just is my bool equals v. So it's just a faster way to do that. It's pretty useful if you have like one-line functions that you'll only need once. Okay, last slide, XAPI. So there is another presentation on XAPI specifically, so I won't go into this too much. I just wanted to show you that it's new and it exists. This is how you use it. So it lives on prop-obj. I'm sure you guys are all pretty familiar with public props now, which came out maybe a few versions ago, but it's with methods. So basically how you use it is you make a method. So here I've got my method and I've also got another, and you add it to the public XAPI. So like this is similar, like I said, to public props. I think you can only have it once in your prop-obj. And then if I didn't have my method or another defined yet, this wouldn't compile. It would tell me that those methods don't exist, so I can't add them to XAPI. I think there's a way to use a different method name than your actual method name, but I would say you should attend the XAPI presentation to learn more on how to do that. I'm sure they'll cover that. And then I can just call it anywhere without needing to cast my snapper using xrun. So this is how you would do that. You can see that I am making my snapper, but I'm actually making it a snapper. So I don't know that it's a my snapper. So if I try to access my method, I would need to cast my snap to a my snapper before I can access my method or another. But now I can just call xrun and then my method name as a string, and then a comma with the parameter IDs and their values separated by commas. And then, so this runs, this will equal 2, which is what I want it to be. So yeah, that's just kind of cool. You don't have to cast. It's just a little faster, and it's really nice if you have a lot of like base classes that have similar functions. You don't have to make like a function to cast to each one to call that specific class's method. This is the presentation that I was talking about. So it's called XAPI and Associative Dimensions Webinar. So same way that you signed up for this one, you can check that one out as well. Cool, that's it. Thank you guys for joining. So I guess we have a few more minutes before 11 hits. Does anybody have any questions or want me to go back to any slides?
Will you be posting this PowerPoint somewhere that we can access it afterwards?
Yeah, definitely. I think that this whole presentation will be posted on probably on the YouTube channel, but
Okay.
I can see if this PowerPoint will be posted as well.
All right, thank you.
Yeah, no problem. Is there anything else? Or if you guys want to see anything, if you want me to go back to any slides, if you're taking notes. Okay, hang on. I'm looking at the chat now. Could you go back to the method as default parameter slide? Yes, I can do that. Are there extra parentheses necessary for if the cast question mark int1 equals obj? No, there are not. All right, well, if nobody has any more questions, I'll stick around for a few more minutes. But thank you everyone for joining, and have a good rest of your day.